Large language models are generally impressive, but they have one fundamental problem. Their knowledge is frozen at the point they were trained. Ask about something outside that window or something specific to your organization, and they either guess or give up. So how do you actually solve that problem? That gap between what AI knows and what you actually needed to know is one of the most important problems in applied AI right now. And there are exactly 3 ways you can solve it: RAG, fine-tuning, and prompt engineering. Most people can't clearly tell them apart. By the end of this video, you will. So let's say here's your model. It has one source of knowledge, everything it learned during training. It's frozen, static, almost done. To make it more useful, you have 3 levers. Lever 1, give it a search tool so it can find information at the moment you ask. That's RAG. Lever 2, retrain it on your specific data so it develops expertise in your domain. That's fine-tuning. And lever 3, ask it better questions to get better answers out of what it already knows. That's prompt engineering. See, same model, 3 completely different approaches. Let's go through each one. RAG stands for Retrieval-Augmented Generation. The idea is quite elegant. Think of it like an open book exam. The student, your LLM, doesn't need to have memorized everything. They just need to find the right page at the right moment, read it, and use it to write their answer. Here's what actually happens when a query comes in. Step 1. The system searches your document library, PDFs, email, internal reports, whatever you have loaded in. Step 2. It finds the most relevant pieces of information not by matching keywords, but by matching meanings or context using something called vector embeddings, which we will cover in a separate video. And step 3, those relevant pieces get handed to the model alongside your original question, and the model answers based on what it actually retrieved, not what it vaguely remembers from training. So what's the trade-off? Every query now has an extra retrieval step, which adds response time. And you need to maintain a document database. That's additional infrastructure that the other 2 approaches don't require. Fine-tuning is a fundamentally different approach. Instead of finding information at query time, you train the knowledge directly into the model itself. Think of it like this. Imagine a junior doctor fresh out of medical school. He has a broad knowledge, anatomy, pharmacology, general medicine, but your hospital needs a cardiologist. So you put them through a cardiology residency. Years of focused cases, specific procedures, domain patterns, that's fine-tuning. You give the model thousands of examples specific to your domain. Here's the question, here's the ideal answer. And through training, it adjusts internally to get better at exactly that type of task. So what's the upside? It's fast at inference, no retrieval step, no database to maintain. The expertise is baked in. But there is a downside. And downside is creating those training examples is expensive and time consuming. You need thousands of high quality labeled pairs. And there's a real risk called catastrophic forgetting, where specializing the model in one area makes it worse at things it used to handle well. And every time your requirement changes, you need to retrain from scratch. Prompt engineering is the simplest of the 3, and honestly, it's the most underestimated. You are not changing the model, you're not feeding it new data. You are just getting better at how you ask. Here's a concrete example. Let's say you ask a model, is this code secure? You get a vague and generic answer. But let's say you say, you're a senior security engineer, review this code for SQL injection, authentication flaws, and data exposure. List each vulnerability with a severity rating and suggest a fix. It's the same model, same code, but you will see completely different output. Adding context, examples, format instructions, step-by-step reasoning, all of it activates patterns the model already learned during training, without touching any infrastructure at all. But there is a hard limit. You cannot teach the model anything genuinely new. No amount of clever prompting will tell it about, let's say, your internal documents, or events after its training cutoff. You are working entirely within what it already knows. So here's the honest one-line summary of each. Prompt engineering, it's free, immediate, zero infrastructure, but can't extend what the model knows. RAG brings in live current domain-specific information on demand, but adds retrieval time and infrastructure complexity. Fine-tuning, deep specialized expertise baked directly into the model, but expensive, slow to update, and risk losing general capability. If you want to go one layer deeper, next video we get into exactly how RAG works under the hood, what vector embeddings actually are, and why most RAG systems fail in practice. Subscribe so you don't miss it.